Do you know how to solve this math problem? Let me show you how. Since we have 4 cubed, we're not, our 4 right here is really a squared number. So we could actually have that as written as 2 squared, right? We also have 32, the square root of 32, which that also could be rewritten as 32 and a half as the index. So we can start right there. The next thing now is that just to actually rewrite that out so we can see what we're working at, we could have 2 squared bracket, that would be a cube, being divided by 32 and a half, right? 32 again could be further broken down as 2 to the power of fifth, or 2 fifth, or 2 to the power of 5 rather, right? So having 2 to the power of 5, we know that we could just to have everything right here, 2 squared bracket cube over, we see that this is 2 fifth, so this is 2 to the power of 5, and we have that bracketed to the power of a half. So that's one of the first place we can actually begin. Now we could just go ahead and actually have this being simplified further as 2 squared. When we have powers being one outside the bracket and one inside the bracket, we know we're going to multiply the powers. So that's 2 times 3 is going to be 6. And here now it's the same thing you're going to hear. So we know that 5 times a half is just going to give me 2 to the power of 5 over 2. So again, now looking at this now, we can have another breakdown of that. And this could actually just be written as 2 to the power of 6 divided by 2 to the power of 5 over 2. So here now we actually have the same base. And what do you know when we have the same base? Well, there's a rule that says whenever we have the same base, we can actually rewrite it and subtract our power. So now we have 6 minus 5 over 2. Now, as we are looking at 6 minus 5 over 2, we know that if we're going to subtract fractions, the way how we subtract fractions is that we have to find the LCM, which in this case would be 2. And we see that 1 into 2, that's going to be actually 2. So we multiply the numerator by what we got there, which would be 6 times 2 is actually going to be 12. And 2 into 2 is actually 1. So 5 times 1 is 5. Alright, so now we actually have 12 minus 5, just removing that 2 so we don't have a confusion right there. So 12 minus 5 is going to give me 7, and we keep that 2 as a denominator. So what we have right here is just simply, just erase this as well. What we have right here is that 2 to the power of 7 over 2. So that's what we have right here. So understanding now that when it comes down to the 2, the bottom number is the root, and the top number is the index or the power. So we could actually have this being further established as 2 to the power of 7. We're actually finding 2 to the power of 7, and we're actually finding the root of 2 to the power of 7. So having that being like that, we know 2 to the power of 7 is going to give me 128. And having that and finding the half, the half power, the index to the power of a half here, we would actually have it being written like this, which would be 128. Now, the root of 128 can be also be further broken down as the root of, we can choose 2 factors of 128, and those 2 factors are going to be 64 and 2. So we have 64 times 2. Now this again could be further written as the root of 64 times the root of 2. And the root of 64 is actually going to give me 8. So the root of 64 is 8. And we know that that is just going to be the root of 2. You know, that's an irrational number, so we can just have it as 8 times the root of 2. And there you have it.